Alright, in this next problem I'm asked to order these from least to greatest. The easiest way we're going to find to do this is just to put these in standard form first and then go back. So when we put these in standard form, we're going to notice that we have a positive exponent here. So I'm going to say that I'm multiplying by a large number, so I want to make this number larger. So in order to do that, I would be moving it to the right. So that actually makes this number be 630. This one again is a positive exponent, so it's making it large, so I'll be moving it to the right, which would be 60,300. And then the next problem here, this one already is in standard form. And then the last one, I'd be moving it 3 places to the right because I want to multiplying by a larger number of 1,000. So I have 63,100. Putting these in order then, this would be the smallest, the second smallest, the third smallest, and then the fourth smallest. So when you'd write your answer, you would go ahead and say that 0.0063 times 10 to the fifth is the smallest. The next smallest would be 6,103. The next one would be 6.03 times 10 to the fourth. The next one would be 63.1 times 10 to the third. Now for the last types of the problems, what we're going to look at is how we deal with these parentheses and do they really matter. And in this problem, I want you guys to know that because everything's being multiplied together, the parentheses really do not matter. We can multiply whatever we want in whatever order we want, and it doesn't matter if there's parentheses there to begin with. That is very different than having something like this, where parentheses do matter, because normally we do multiplication and then addition first, and here I'm saying we have to do addition first. Well, here when you have all multiplication, it does not matter the order in which you create that multiplication. So while some of you are going to think we need to distribute to both of those, that's not the case, because it's not a plus sign between them. It's not being distributed to both of them. It's really just saying you have 2.5 times 6 times 10 to the third, and with the associative property, we can actually move those parentheses in whatever order we want. So I'm not even going to put the parentheses there. I just want you guys to know that there does not need to be parentheses here. We're going to go ahead and multiply then 2.5 times 6. 2.5 times 6 is 15, because I'd be moving that over one spot, which would give me 15.0. So I'd have 15.0 times 10 to the third. The problem with this is now it is not in scientific notation, and a lot of times I want it in scientific notation. My suggestion is go ahead and change it to standard form first. Move this over 3 spots to the right because we will need to make our number bigger, which gives us 15,000. That will allow you then to change it into scientific notation, looking for that spot where that decimal would need to be placed, which would be between the 1 and the 5. And then you will be able to put that in scientific notation without trying to figure out or come up with some rule. A lot of people want to come up with some rule and then they have to memorize that rule. In this case, we're just thinking about it logically, so there is no rules to follow. We're just using our brains to think about it. So we want 1.5, and that means we would have moved our decimal over 4 spots, and it would be a positive 4 that we want because we want our 1.5 to get really, really large. We really are just saying 0.4 times 2 times 10 to the negative 9th. Well, 0.4 times 2 is 0.8 times 10 to the negative 9th. This is not in scientific notation. So let's change it into standard notation first. So I'd have 0.00000. I have to move that decimal over 9 spots, so I have 9 zeros. I've got 3, 4, 5, 6, 7, 8, 9 zeros now. 8. That's the standard form of this, or standard notation. I shouldn't say standard form. Now to put it in scientific notation, I know that my decimal needs to be right here behind the 8, so the number is between 1 and 10. So I have 8 times 10 to the negative 10th power because I need my 8 to be really, really small. The last problem I squeeze in here is 48 times 10 to the negative 4th. 48 times 10 to the negative 4th is 1234.0048. And then put that in standard or in scientific notation, I'd have 4.8 times 10 to the negative 3rd. I need that decimal right there, and I need to make it smaller.